Welcome back. By the end of Lab 3, your application should be anonymizing patient data and outputting average moving heart rate readings. If you could not get these things working, I will show you how. If you completed the lab successfully, you can skip this video and start on Lab 4. In this lab, you will be doing your development in the coding cell under the Lab 3 heading. Before you begin this lab, you should have a completed version of Lab 2 copied and pasted into the cell. If you did not finish Lab 2, you can copy the code from the Course Solutions notebook. The first step of this lab is to anonymize patient data by hashing the tuples. For this, you will need to import the hashlib module. This module contains the hash function that you will be using to hash your patient data. To respect privacy, it makes sense to do the data anonymization first, before the patient's data is processed. Create a new stream patient X by calling the map function on the patient data stream. Now you need to define an anonymization function to pass to the map function. Before you do that, though, let's take a look at what patient data you will be hashing and how to access it in the tuple. There are two important fields that your function will have to hash: the patient ID and location ID, both of which could be used to identify the patient. The patient ID can be accessed under tuple patient ID, and the location ID can be accessed under tuple device location ID. Call your function Anonymize. It should take one tuple as input. You will be using the SHA-256 hash function to hash the patient data. The instructions for hashing data are listed in the lab documentation. We won't get into specifics about the hashlib module for now. Hash the patient ID and location ID, and then make sure your function returns the modified tuple. Now you can pass your anonymize function to the map function. Change the filter function below to reflect this new stream. Run the cell. Let's view your output in the streams console. If all goes well, then the values for both location ID and patient ID should have been replaced with hashes, making it impossible to tell what the patient's number and bed number is. Once you're done looking at the output data, cancel the job. Now let's go back to the notebook and get started on averaging these readings. To make this easier for you, there's a function called getReadingValue that returns the reading from one of the patient data tuples. Import it from the observation module. Next, you'll take the average of several of these values. This will require a stateful function to hold the values in memory. Create an average heart rate stream by calling the map function on the heart rate stream. Now you will have to write the class to pass to the map function. Call the class average. Define an initialization method for your class. Pass in the tuple itself and a variable n. N will represent the number of tuples over which to keep state, which is the window. Create instance variables for n and for last n, which will be the list that holds the last n number of readings. It'll be blank for now. Now define the call method. As parameters, it should have the average instance itself and the newest tuple to be added. Every time the average instance is called, it should append this new tuple's reading, which it can get with the getReadingValue function, to the last n list. If the list is already full of n tuples, it should pop the oldest tuple to make room for the latest reading. It should then return the average of all of these readings. Since you want to keep track of the last 10 tuples, you can pass in an average object with n being 10 to the map function. Remember to print the new averaged heart rate stream instead of the old one. Run your cell and navigate to the streams console to view its output. The output here is very simple. Most of the patient data has been removed, leaving only a clean list of numbers that are now the average heart rate readings of your patient. In all, you've managed to anonymize the patient's data, filter out non-important readings, and average their heart rate, thus completing a fully functional application. In the next lab, you'll visualize your application in the Python notebook.